All right, so we're looking at scatter plots, and I'm also going to look at variables and relationship between variables, independent variables and dependent variables. But in further maths, and the reason why we're doing this is for next year, we're actually going to be looking at, rather than independent variables and dependent variables, we're actually looking at this EV and RV. Okay, now what does that mean? Well, if I have a look at the first page, the explanatory variable, previously known as the independent variable. Your textbook is going to be talking this sort of language, and your exams next year are going to be talking this sort of language. So, explanatory variable. The explanatory variable explains the independent variable, in other words. So, as I suggested before, your exam results, you could have exam results, and your exam results could depend on the time you spent on your exams. So this could be time studied. Time studied. Now, of course, we used to know this as, say, our dependent variable, and this was our independent variable. So now the response variable is your dependent variable. So let's have a look at that. So exam results would be your response or response variable, isn't it? So your exam results would be the response variable. An explanatory variable is like your independent variable. So I just want you to get your head around the language. It's sort of recently changed. I've always known it as independent and dependent. But especially when you get your textbook and stuff next year and they start talking explanatory variable, let's get a head around the lingo for the time being. So let's go back to where we are now. And the explanatory variable and the response variable, and label the axis. So let's do this example here. We've got the data below shows the number of people in a cinema at 5-minute intervals. Construct a scatter plot. So that's all we're doing in exercise 4A. So first of all, we know that our number in the cinema, probably, what does it depend on though? Which is our dependent variable, or what do we call the dependent variable now? The response variable. So what is our response variable in this example here? The number in cinema is in response. So the number in cinema is going to go here, isn't it? Now, quite a few of you in your exams and things, I know in my class, didn't label axes. It's easy marks. You always have to label every axis, and you have to have correct units. And if you're drawing a graph, you have to have a correct scale and so on. And then I've got time in minutes. Now, generally speaking, not always, but generally speaking, time is our independent variable, or what do we know it as now? Explanatory variable. So this is time is in minutes, and that's our explanatory variable. And number in cinema is our response variable. Now, if you get these, there are some cases where you can get these mixed up. And this is probably not the best example. But there have been some occasions where time, rather than time being our explanatory variable, it actually can be our response variable. It can be. So be careful. That can be the tricky part to bivariate data. So let's do it. Time minutes. Well, we've got time in minutes is here, this being our origin, 0. And let's go to 87, which is, well, if we're going up in, that's 82, 84, 86, 88. So we're looking at right there. Let's mark that out. And a scatter plot, though, is this just like a straight line, do you think? No, it's gonna vary. And we're going to have some relationships which are linear, some which are not linear at all. And that's what we're sort of going to have to determine. We're going to have to, first of all, sketch them out. 5 and 102. So I'm going to say 5 and 102. These are going up in 2, so that's going to be there. And 10 and 118. 10 and 118 goes there. And 15 and 123. Well, 123 is going to go about there. And 20 and 135. 20 and 135 is going to go about there, isn't it? And 25, 137 is going to go here, I think. Now, clearly, if I was to draw a straight line between all of those points, I can't. I'd have to have like what's called a line of best fit, and we're going to get through that later. So let's just say if I sketched a line which goes sort of through those points, some points are going to be above, some points are going to be, but you wouldn't sketch that. We've actually just sketched these points, and this is what we call a scatter plot. It's not joining the dots, okay? It's not sort of like, you know, your little activities you had when you were 5 and 6, and you're going to join the dots and all that sort of thing. It's not that, okay? But we can start joining the dots and finding some relationships between these variables. But for the time being, that's pretty much all you're doing. That's for 4A, the questions in 4A. And does it say what questions we're doing?
Always on the next page.
It should be in your course outline. Does it say what questions?
Do you always have to do a line of best fit with the scatter plot?
Questions 1, 3 and 5 it says we're doing, by the way. It says it on your course outline. So questions 1, 3 and 5. What was your question, mister?
Do you always have to do a line of best fit?
No. You'll be asked to do things such as lines of best fit, okay, but that's going to come a bit later.
So say that this was the question.
Go. So, first of all, when we're looking at scatter plots, we're going to have all of these different types of relationships. You can see here that the first one here, it's certainly an indication that as we go up in our independent variable, or what's it called? What's this variable called? Independent variable? Explanatory?
Yeah.
So, as we go across in our explanatory variable, what's happening for our response variable? What's happening?
As one goes up, the other goes up.
Yeah, it tends to, doesn't it? But it's quite a weak positive relationship. Like if we had, it's pretty hard to sort of draw a line of best fit down the middle because you've got all of these ones on this side and you've got all of these ones on this side. Now we're going to eventually look at some fitting these lines and using this data and actually getting what's called there's a certain number which basically tells us whether we've got a weak, a strong or a moderate relationship. We're going to get to that stuff later. But just graphically, you can notice that this here represents a much better line. We've got some on this side, we've got some on this side, but it's a moderate relationship between our explanatory and our response variable. But of course, this one is a pretty good straight line, isn't it? So that's actually good. I'll just go back here, and I'll do this. Is that better? Hey, all right. So this one's quite a strong one. You can see here though that we've got, but these are all positive relationships. So if you're asked to explain what type of relationship is, there's a few things. First of all, it's whether it's moderate, weak, or strong. And the next things are whether it's positive or negative. Okay, so that's step one. Then we have to ask ourselves, is it positive or negative? And then the last thing we have to ask ourselves, is it linear or is it non-linear? And of course, they don't all have to be linear. For example, what happens if I had this scatter plot here? Clearly, it just indicates that there's no relationship at all. So it doesn't have to be linear. Okay? Certainly, if I had something like this, now you people have done methods, okay? This is not a linear relationship. What's this one? It's like a parabola, this one. Quadratics, you might have done that in year 10. So it doesn't have to be linear. So, and the only time you get a perfect is it's exactly that. Now, do we really ever have a perfect relationship? Well, if you're doing tests, generally not. Okay? There's always going to be some outliers. There's going to be some things that, we might have something like this, but if you might have a couple of values out here. and they're sort of considered outliers. Okay, if we're drawing a line of best fit, we're not going to sketch the line up here because of one value. All right, so that pretty much describing that actually goes through 4B. Now this scatter plot here, let's sort of look at this scatter plot. If you were given a question like this, if I was to draw a line between sort of here and here, sort of somewhere in the middle, what would you say about this relationship? Is it why did that disappear? That's strange. There's some lag in here. I'm not sure what's going on. I think it's my network. It's really slow. So sorry about that. How would you describe it? Is it a perfect relationship? Is it a strong?
Moderate.
Yeah, I'd say that this. So first of all, we've got to ask ourselves: is it a strong, weak? So this is going to be a moderate. What? Positive. Linear relationship.
So the last step is positive or not?
That's exactly right. So there's three things. 1, 2, 3. Generally speaking, you're going to have a linear relationship when we're doing bivariate. So a lot of the time, if you had to guess, you'd guess linear. All right, but you should know that anyway. Then whether it's positive or negative, and of course if it's weak, strong or moderate. A lot of the time they're moderate, if I had to have a guess. But in this case, yeah, definitely moderate. Now the questions you had to do from 4B were also in your course guide, which was, well, all of them, because there's actually stuff all to do anyway. Okay. Now, for the time being, I'm going to stop that video there because it's probably gone for about 10 minutes, 11 minutes.